Hey everyone, this is Mayur. Welcome back to MLWorks. In this video, we'll try to understand this new library called as DSPy, which is integrated with the foundational models or foundational model providers and helps you to fine tune or prompting, building RAG systems or creating applications like Q&A or summarization. So all this can be done using this particular library. So as part of this video, what we'll do is we'll try to understand DSPy, what is the workflow of a DSPy task, and we'll try to implement a RAG-based system, a simple RAG-based system, or we can also look into a multi-hop Q&A kind of a task that we'll implement using DSPy. So with that, what we'll do is we'll try to get started with this notebook, and just to give you a note, so this notebook is available in their official repository. Then you can directly go ahead and use it. Okay, so let us understand that whole notebook here. So first is we'll just go to the installation aspect. So we just have to clone the repository and import the package. So let me run. It is already executed, so it is already available. Okay. So with that, once it is installed, we'll be importing the DSPy, and then we'll try to, since I talked about, we'll be using language model, and also we'll be talking about RAG, which is also nothing but retrieval-augmented generation. So one of the concept there is retrieval. So retrieval is nothing but you have a list of or a vector index of documents, and you try to pull similar documents based on the query. Okay, so we'll try to implement that using Colbert, okay, which is having an index of the key articles or abstracts, and we'll try to pull that out using Colbert v2. Okay, so now what we do is first we initialize GPT 3.5 model and Colbert, which are integrated to DSPy, and we are setting it as part of its configuration here. So as I said right earlier, like it can be integrated with LLM providers like OpenAI, Anthropic, Cohere. So you can directly use those integration and mention the particular model that you want to use. You can also have to add. You also have to add API key for certain LLM providers. Okay, so that is it will be part of your ENV variables. Okay. So once that is done, okay, once we have configured the LLM model and also the retriever model, we'll talk about what is DSPy programs. Okay, what is the flow that a program flows through here, right? So basically, you have a language model. So you pass in some data, which is called a little bit of data, which is few shots of your data. Okay, which will be part of your training aspect, and you write a program. A program is nothing but a task that you want to achieve using language model, and for that you will be passing what is the input, what is the output, what is the kind of output you are expecting, and what is the prompt that you are giving. So all those will be your part of your program, and once that is done, you will be having a validation logic which will be applied on the generation that is done using LLM model. And then you also compile using your program, using your data. So that is where you will be compiling what the task that you have given and the data that you have passed. So that is the compilation task. Okay, so once you have compiled, once you get the results, you iterate. If the results are not good enough, then you reiterate through the whole process and improve your system. Okay, so that is what the whole flow of DSPy looks like. So let's get started with example called as Q&A. Okay, so first is we are downloading a data set hotpot QA. Okay, so let me run this cell first. So hotpot QA is nothing but it is a question answering based data set where you download. You will be given a list of variables or features, and corresponding label will be the answer. Okay, so what we do here is in the training set we fetch only questions, and dev set we also have questions, and we create our data set. Okay, which will be sent to the LLM model. So if you see here, we are giving the train seed as 1 and train size as 20. So we are taking 20 samples since it is a few short learning only. So we are just taking train size as 20 and dev size as 50 samples. And then here what we do is we are just creating a sample or generating a samples out of it. Okay, by giving this dev size 50, and also uh, test size 0. So these are like the way you are splitting your data set. Okay, that's what is happening here. So once that is done, okay, what we'll have is we'll load 20 examples in train set and 50 examples in dev set, and each example will contain a question and its answer. So DSPy, as I said, it requires minimal labeling. You can also create your own data set and use it here with DSPy, and you create a pipeline as I mentioned the earlier step. Okay. So once if you want to modify your pipeline, you can do that as well after a part of your iteration, right? You can modify that as well. So here what I said is we have created a data set, and then what we do is we just look at one of the samples from the data set. So it's taking a little bit of a time here. Okay, so we have the split is done. Okay, it's 2050. Train set has 2050 as the dev set. Okay, and then if you run this, you're getting the first sample. At my window was released by American singer songwriter. It is giving that answer. This is part of your training set. And then we look at the dev set where you have question answer and retrieval relevant Wikipedia titles. Okay, so as I said, this is a Wikipedia 17 abstracts. So along in the dev set, what we have is we have question answer. Along with that, we have something called as Wikipedia titles, which is part of the data set. So this will help us in understanding the results what we get. Okay. So after loading the data set, we are just running this to cell. What is the key and what is the label here? Okay. So once that is done, so this is the first part, okay, where you have little bit of data. Now you are building block, okay, which is your program. You are writing your DSPy program. So where you will be mentioning your task, what is the input, output field, everything. So as mentioned, okay, which is nothing but in context with DSPy, it means signature and predictors. So signature is nothing but what you are taking, right? What is the task? Okay, so here we are inheriting the properties of signature from DSPy, and we are creating a class called as basic Q&A. So here the input field is nothing but question. So you can also, so if as part of the class also, right, we are passing this doc string, okay, which is nothing but a prompt that will be sent to the LLM model. And this here we have another variable called as question, which is nothing but your input field, answer, that is your output field, and we are adding a description which is optional. Okay, in this case it is often the answer should be between 1 to 5 words. So with that in mind, what we'll do is we'll use something called as DSPy.predict and pass this signature to it, and this will turn this signature into a predictor. Okay, so this is your signature from DSPy, okay, the class basic QA, and we pass that to DSPy.predict and turn that into a answer predictor. And when a question is given to this particular answer predictor, it will give you the answer. So let me just go back here. If you run this cell, okay, let me run this cell first and then run this cell. So here, what is the nationality of the chef and restaurant or featured in Restaurant Impossible? Predicted answer is American. But if you go here, okay, in the first dev set, okay, what is the nationality and restaurant featured in Restaurant Impossible? The answer was English. So this LLM model, okay, was not able to correctly answer this question. Okay. So what we'll do is next we'll inspect the history, what was happening, right? So we'll understand that. So here just we gave a simple query, and the language model, whatever the information it had, okay, with respect to this particular restaurant, it gave the answer as American. Okay, so now what we'll do is we'll have to include some kind of a thought process in the LLMs. So what we'll do is instead of just giving DSPy.predict, what we'll do is we'll turn that into a chain of thought. Okay. So based on the query, it has to think about what exactly the query is and it has to answer accordingly. Okay. So what we do is we have the same signature. The only module we are changing is instead of predict, we are giving chain of thought, and then we create a predictor, and now this predictor we pass in the same question, and then we get these kind of solution here The question is, what is the nationality? The same question. What was the rationale behind the answer it has given? We know that the chef and restaurant featured in Restaurant Impossible, this is Robert Irwin. Based on this specific name, okay, the model was able to identify the predicted answer is British. Okay, so it was able to identify the nationality is British by just changing this chain of thought. Instead of just giving dot predict, if you put chain of thought, okay, it was able to identify the nationality of that particular person based out of his name. Okay, now this is one way of what improving your Q&A. Okay, now what we can do is we can also bring in something called as retriever model. Okay, which is nothing but based on the query that you're passing, there are relevant documents to that specific query, and use that relevant documents with along with the query and send it to a large language model. So in this again in this sample, what we'll do is the retriever model is nothing but which I talked about, which is Colbert V2. That is the model we are using, and what we want is we want to fetch the top three similar documents. Now retriever, we pass in the sample query and we get the passages, retrieved documents. We iterate through them and we get the top three similar documents. So based on that specific query, it was talking about Restaurant Impossible. It is talking about another chef and whatever his foundation was, and the list of Restaurant Impossible episodes. Okay, so it picks up top three documents based on the query that was passed to it. Now we can also what add any other query which we want to test. Right, when was the first FIFA World Cup held? And it gives us the retrieved documents. This is the first document of this for the specific query. Now we talked about dot predict. Okay, how we improved it using chain of thought. Now further improvement can be done with having a RAG system or retrieval system. Okay, so we talked about retriever. Okay, now we'll talk about RAG. Okay, where we'll be using the relevant documents along with the query and then generate a result. So for this, what we have to do is again we have a class, okay, and again we are creating a signature. Earlier we had a signature basic QA. Okay, now we are turning that into a generate answer where we are passing the same doc string. Okay, and we are just adding something called as context, which may contain relevant facts. So this is nothing but the relevant document that you are pulling from the retriever that will become part of your context. Okay, and the question is nothing but the query that you are sending, and the answer is something that is generated by the LLM model. So with that in mind, let's go back to RAG system here. So a RAG is nothing but you have a retriever and then you have a generate answer module. So first thing is retriever, and you pass the number of documents that needs to be retrieved, and then how that retrieved context and the query needs to be passed to the generate answer. Okay, which is passed through this particular module called as chain of thought. So here what we do is first we get the passages, relevant documents. Then what we do is the question that we send along with the context, we generate the prediction. Okay, and that prediction here, again we are getting it here. DSPy dot predictions, we are passing it here along with the context and prediction dot answer. Okay, so let me first run this cell. So let us see here compiling the RAG program. So here we have just defined the class for RAG. Okay, now what we'll do is we'll run a RAG system where you will have the index and where you will have the search query. Okay, and how the whole process will flow, right? So those things will be done here. So first is the training set, that is 20 question and answer from the training data set. What we do is then we metric for validation. We validate the answer generated by the LLM model and also the retrieved documents that we got from the retriever model. So we want to ensure the answers generated by the LLM model and the retrieved documents are relevant. So we have to validate those aspects as well. Otherwise, we have to go for a better retrieval model, or a better language model. Okay, that's why we have to validate. And then what we have is something specific to DSPy is a teleprompters. Teleprompters are nothing but your way of optimizing your DSPy program. Okay, it will try to generate or effective prompts for your task based on the data set that you have. Okay, so if you see here, the definition of teleprompters are a powerful optimizers that can take any program and learn to bootstrap and select effective prompts for its modules. So you have all these modules here and you are trying to effectively generate prompts for them. Okay. And one of the prompt is bootstrap few shot. So it will select few samples from your data set. Okay. And try to optimize or find a better effective prompt for improving the results. So as I compared earlier, right? So with the neural network here, you can talk about the training set has your training set with the neural network in the neural network. And metric for validation is nothing but your loss function, and an optimizer is in neural network is nothing but SGD, stochastic gradient descent, or ADAM RMS prompt. So here teleprompter will act as your optimizer. So let me run this teleprompt where I have, let me run this. So where I create a function called as validate context and answer. So the context is nothing but the retrieve document, and the answer is nothing but the LLM language model's output. So yeah, so once this is done, so here what we are doing is first we are creating a function of validating the context and answer, and then we have teleprompter which will based on these parameters, okay, based on these parameters, and also at the end we are also passing the data set, okay, based on these things it has to generate the prompts or Q&A kind of questions, and it has to validate in the backend. So now let's go to our RAG-based system, right? Since we have compiled the RAG here, okay. And my question is, what castle did Dave Gregory inherit? Okay, the compiled RAG, we are passing these questions, and then we are generating our answers. So here, what castle did? Okay, it gave this particular okay answer, and then it retrieved context. What was the context that was used to generate this specific answer? So David Gregory, okay, is a Scottish physician and inventor. His surname is something something, and he inherited something here. Okay, it is talking. It is already giving here the answer. Okay, this is one. Similarly, there are top three documents are present, so we are taking all the top three documents here. Now we are looking at the inspecting the history. So this is the turbo inspect. Okay, let me. So here, so when you inspect the history, okay, it will talk about all the teleprompters. Okay, what was the last prompt that was given by the teleprompter as well. Okay, these was the prompt. So these are the prompts that was given. Okay, these are the set of prompts it has selected, and these are the context it has selected, it has generated. So all these are part of your teleprompter's output. Okay, so based on that question, okay, what we got, okay, this was the retrieved document for the particular question what we sent, which what castle did David Gregory inherit. So based on this context and this query, it has generated this solution. Okay, this is with respect to RAG where you have input query and then you retrieve a result and then a result, that is your LLM result. Okay, so there is also something. As I said right here, if you read through, we see that DSP was able to bootstrap this 3000 token prompt for 3-shot retrieval augmented generation with hard negative passages and a chain of thought from our extremely simple program. Okay, so it was able to generate all these things, okay, by using just a simple kind of what we call chain of thought and also RAG kind of input we have given. Okay, a very simple program if you look at. Okay, it's a very simple program here, right? So based on that, it has able to generate so many things here. Now, okay, so we can talk about what each of those predictors, right? Whatever we got, we can look at each of them, name and parameters. Okay, so that is a separate task. Okay, now what we'll do is, so we have seen the results that we got, the context that got generated or retrieved. Now we can evaluate those things. Okay, so What we'll do here is we have this hotpot QA and we have the dev set. Now what we'll do is we'll try to evaluate for the whole data set, dev set, and see how much it is relevant answers are there generated by this LLM along with the RAG. Okay. So I think we are still using the RAG here. Compiled RAG is being used to evaluate. So let's see. So we pass the data set, and then we are also the metric that we are using for evaluating is the exact match of the answer. Okay. So once you run it, let me run this first. Okay. So I guess I have executed this one. Okay, it's not required to execute this one. This is just a inspect history. Okay, so let me run this one where we evaluate. So here we are looking at a display table of 10. It will give you show the 10 results from the dev set. So it is happening, it has executed and it is giving a 44 percentage. Okay, 22 answers were correct with the exact match. Okay, so if you see here, the question was this one, the answer was, example answer was no. So it was able to predict the answer. The exact match was true. Now go to this second statement as well. Who conducts the draft in which, okay, this is the example answer. The predicted answer was this and this is true. Now this is the golden title which is possible, which is available in dev set alone. And this is the context. This is from the retriever document, right? 3 documents that got retrieved. That is the result here. Now what we'll do is we'll evaluate these things that we got from here, the retriever result. So it may also be instructive to look at the accuracy of the retrieval. Okay, there are multiple ways to do it. Often check whether the retrieved passage contains the answer. So the way we are evaluating the retriever is the answer that we got. Okay, is it present in the retrieved documents? So then it is a properly retrieved document. Okay, so that is the way it has been evaluated here. So we are evaluating, we are normalizing the text. Golden titles are present and normalize the text, and whatever the predicted context we got, we are iterating through that and we are just comparing. Okay. So in number of cases it has worked, right? So golden passages retrieved. So in many cases, okay, if you see here, no, the keyword no is not present in the context. Okay, it makes sense anyway because the answer was no anyway. But if you look at the second retrieved document, right, where you have predicted answer National Hockey League, it is part of the retrieved document. So that's why it is given true here. So that's the whole logic here, how we are evaluating the retriever. So next what we do is, although this simple compile drag program is able to decent fraction. So as per this notebook, right, so the results that we got from the retriever are mediocre. Okay, so this could be improved. And also if we see the previous result rate for the answer Q&A, it was only able to predict 44 percentage out of 100. Okay, only 22 out of 50. So these things could be improved. And further, what they suggest is instead of going one question, right? You have one question and one retrieve document. You can ask multiple questions based on your understanding from the retrieve document, and then again push back to the LLM model. Okay, that is called multi-hop search. Okay, so let's understand this approach, right? These systems read the retrieved result and then generate additional queries to gather additional information if necessary. Okay, so these kind of tasks, right, can be implemented using DSPy quite easily. So let me go back here. So here we have the same signature, okay, where we have input field, the same input field, and only thing is the prompt has little bit changed. Write a simple search query that will help answer a complex question. Okay, the prompt has changed here a little bit. Write a simple search query. We are not answering here, we are creating a search query. So that is the point here. Okay, so since you are doing multi-hop search, from one search you will be generating some bunch of result. From that result, again you will be asking some questions, and based on that question and answer, okay, then you will be going to the final result. So this is the generated search query. And here, if you see, we have something called as, we are creating a class called as simplified Boolean, okay, which is the concept actually, it's a concept. Okay, so how to do multi-hop search. So here what we do is we create a simple Boolean where we have init function and a forward function. In the init function, as expected, you have chain of thought and you want to do chain of thought on multiple hops. So since it is a multi-hop, you can give multiple hops. Like after one search query results you get, you want to again look for a better search query or a better answer. So you do another kind of pass it to another LLM model. The same LLM, you pass it again, the search query. You create a search query and you pass it. So DSPy dot chain of thought, you create two chain of thought and you create a search query. Okay, and then you have retriever, the same thing. Okay, as earlier, and then you generate answers using chain of thought. Okay, so in the forward function, what we do is we iterate through the hop, we create a search query, and then we pass it to the retriever, and then we kind of want deduplicate. Okay, if there is like duplication of results right from the previous query and the next query, if there is a deduplication is there, we try to avoid that, and then we pass it to the generate answer, which is nothing but your large language model. So this is the whole flow for Boolean. Okay, let me run this. We have created simplified Boolean program here where you iterate through the hops, generate the queries and pass it to the retriever. Top k documents are generated and then we get the result. Okay, using generate answer. So what is the explanation, right? Again, if you go to this explanation aspect, for each loop, we will generate a chain of thought predictor with the generate search query. And retriever is nothing but this module will do the actual search, and using the generated queries it will generate the retrieved documents will be done, and that will be passed to the generate answer, that's just nothing but your predictor. Then there is forward method which will iterate through the self hop, and it will what first generate the query and then it will pass it to the retriever and generate the passages, and that passages will be what going through the deduplication phase such that the passages or the retrieved documents are not duplicated. Okay, so those things are happening here. So that is the whole Boolean program is all about. Now what we'll do is, so this is one part, okay, where you are just creating LLM model. You are not passing any training data set to it, and you are just creating as a multi-hop based RAG approach. Okay, multi-hop based RAG approach. And what we'll do next is we don't pass the training data set. We just do something called a zero-shot version of Boolean program where you don't pass the training data set. You just pass in the query and get the results. Okay, so we pass in this query, okay, and we are not passing anything to this particular Boolean program or any training data set, and then we get the results. Okay, it has also generated certain retrieved documents, and we are also getting the predicted answer as 5. Now, based on this output also, right, what we can do is we can look at the history or history of the whole query, right, what we are inspecting the history, last 3. That is a separate concept. Okay, that is, we can skip it here. Now what we'll do is we'll talk about the validation aspect, and then we'll talk about the compiled version of Boolean program. So validation is nothing but, so here we have again the answer from the large language model, the retriever context, and then we have the queries that are getting generated, okay, and how those queries should be. So the predicted answer should match with the golden answer. The retrieved context should contain the golden answer, and the queries that are getting generated in the multi-hop, it should not exceed 100 characters, and also the queries are not repeated. So those are the some conditions or constraints that we want to push in, so that we are validating here. So all these if blocks, right, it is referring to each of the statements that I mentioned here. So if, and then the hops, right, in each hops what we are getting, like this question that is getting generated, is it greater than 100 characters, or is it repeated questions that we are getting asked. So those things are validated here. So let me run this. So once this is done, what we do is we have the same thing, teleprompter, that generates effective prompts. Okay, and it will try to what validate, and we are passing this metric also here. Now, teleprompters.compile will contain the simplified Bayesian program, and the teacher for the simplified Bayesian program is the training data set that we pass here. So, this is the compiled version of Bayesian program. So, let me run this. So, here, once it is executed, so it is taking some time. So, what we'll do is once this is compiled, okay, so we'll pass in our data set, right? The dev data set also. We'll try to evaluate that. So here, once this is compiled, uncompiled Bayesian retrieval score. So here they are looking at uncompiled version of it. What was the result we got earlier? So I have to go back and I have to run, I guess, uncompiled version, uncompiled Bayesian. So let me copy and search this specific. So let me, I didn't think I didn't run this thing. Okay. 1 billion it is executed here. Okay, now we'll be seeing that. Okay, let me run this now. Retrieval evaluation on hotpot QA using uncompiled billion. So this will also give us the results, retrieval score for all the retrieved documents. So again, we are passing the, we are also metric, there is an evaluation metric that is getting executed here. So here if we see out of 50, 18 were answered properly. Okay, and okay, so this is the case for uncompiled Bayesian retrieval score. Now what we'll do is we'll do for the compiled version. So if we look at here, so out of 50, it is able to answer around 30, which is 60%. Okay, so let me go to this retrieval score right here. So it is given here retrieval score for RAG, okay, which was done the first time. Okay, it is 26. And uncompiled Bayesian gave us 36% accuracy, and retrieval score for compiled Bayesian is 60%. So what it means, right? The RAG multi-hop search RAG with the training data set has performed better than uncompiled version of Bayesian or just a simple RAG without multi-hop search. Okay. So that is the whole results represents. Now, what are the things that you can do to what improve system? This is what it is, and we can also what look at the history of this compiled Bayesian, right? The results that we got. So these are some questions. These are the questions that got generated, context that got generated. Okay, and what was the query? Okay, it looks like since it is multi-hop search, there are multiple questions that is getting generated. Okay, and so if I see here, this is the data set, training data set, which is passed to it. These are the contexts that got generated. And so as part of that context, okay, here, this is our question, okay, and it is able to answer that based on this context. According to context intelligence set, tower with 5 stories and a garret. Okay, and it was able to identify it is 5-story building or a castle. So this is, we are at the end of the notebook. Okay, we looked at a bunch of things. One is DSPy.predict, which gives you simple LM result, and if you give pass in chain of thought, it gives you a better result. And then if you then talk about drag, you can use drag, and the top key documents can be retrieved along with the query. You pass it to LLM model and you get a better result. And then you pass multi-hop, you create a multi-hop search using the RAG approach, and then you get a much more better result. So with that, we are at the end, and I think we are good to go. Yep. Thank you so much.